morning, students. I am Dr. M. Haridas, Associate Professor, Mechanical Engineering Department, Mahendra College of Engineering, Salem. Our title is Introduction to Finite Element Analysis. Before going to study about the finite element analysis, you should know the concept of engineering analysis. This engineering analysis is one of the stage by the manufacturing of products. What is the objectives of engineering analysis? The engineering analysis is a stage that every product should be analyzed by the number of parameters. During the calculations, you need to find the displacement at certain points, stress distribution, natural frequencies, critical buckling loads, vibrations, pressure, velocity, temperature. These are all the parameters you need to calculate during the analysis. This is the objectives of engineering analysis. What are the methods of engineering analysis? What are the methods of engineering analysis? The three methods are fundamental. One, that is experimental method, analytical method, and numerical method. First one is the experimental method. The experimental means the prototype can be used. The prototype means duplicate. If we want to change the dimensions of prototype, we have to disassemble the entire prototype and reassemble it, and then testing should be carried out. It needs manpower and material, so it is time consuming and costly process. This is the experimental method. Next one is the analytical method. Another name is called the theoretical analysis. In this method, the problems are expressed by mathematical differential equations. Every problem should be converted into mathematical form. It gives the quick and close form of solutions. It is used only for simple geometrics and idealized support and loading conditions. This method is specially used for simple geometry and idealized support conditions. This is the analytical method. Third one is the numerical method. This is very familiar to all. The analytical solution can be obtained only for certain simplified situations. For problem involving complex material problems and material conditions, that is a boundary condition, the engineer prefers the numerical methods that gives approximate but acceptable solutions. These numerical methods having three subdivisions. That one is the functional approximation, finite difference method, and finite element method. You see, these are all the categories comes under the numerical method. That one is functional approximation, finite difference method, and finite element method. What is functional approximation? The classical methods such as Rayleigh's method, that is simply called as Ritz method, Galerkin methods. This functional approximation comes under Ritz and Galerkin methods. Every problem to convert in form of functions and vary in their procedure for evaluating the unknown parameters. This function having known parameters and unknown parameter, you need to find the unknown parameter with the help of Ritz method and Galerkin method. Especially the Ritz method is useful for solving the complex structural problems encountered in finite element analysis. The weighted residual method is useful for solving the non-structural problems. You should know very clarity about Ritz and weighted residual. The Ritz method is specially used for structural problems. The weighted residual method is used for non-structural problems. Okay, this is the main for functional approximation. Second one is the finite difference method. The finite difference method is useful for solving heat transfer, fluid mechanics, and structural mechanics problems. It is general method. It is applicable to any phenomenon for which the differential equation along with the boundary conditions are available. It works well for two-dimensional regions with boundaries parallel to the coordinate axis. You should know this is the method to difficult to use when regions have curved or irregular boundaries, and it is difficult to write the general computer programs. In case you need to find the curved or irregular boundary, means we need to approach the computers. This is the finite difference method. Third one is the finite element method, sometimes called as the finite element analysis. The finite element method is a numerical method for solving problems of engineering and mathematical physics. This is the general use by the finite element method, to solve the numerical method for solving problems of engineering and mathematical physics. In this method, the body or structure in which the analysis to be carried out subdivided into smaller elements of finite dimensions called finite elements. Then the body is considered as the assemblage of these elements connected in the finite number of joints called nodes. The properties of each type of finite element method is obtained and assembled together and solved as whole to get the solutions. This is the process by the finite element method. The simple definitions shows the finite element method. Different peoples giving the definition by the different ways. It is one of the definition. The finite element method, instead of solving the problem for entire body in one operation, we formulate the equation for each finite element and combine them to obtain the solution of whole body. This finite element method is used to solve the physical problems involving the complicated geometries, loadings and material properties which cannot be solved by analytical method. This method is extensively used in finite, that is the field of structural mechanics, fluid mechanics, heat transfer, mass transfer, electric and magnetic field problems. This is the main application of finite element method. Then anyway, you need to know the basic applications. The finite element problems are classified as two types. One in structural problems, another one is non-structural problems. What is structural problem? In structural problem, the displacement at each node point is obtained. By using these displacement solutions, stress and strain in each element can be calculated. This is called the structural. What is non-structural problems? In non-structural problems, the temperature or fluid pressure at each nodal point is obtained. By using these values, the properties such as heat flow, fluid flow, etc. Some of the activities for each element can be calculated. This is called the non-structural problems. This is the finite element method. This technique is latest one, but latest means this decade. This only introduced in the 19th century by the finite element method, not for before 18th century. First, the basic idea of finite element analysis was developed by aircraft engineer in the early 1940s. These were primarily the matrix method of analysis. The modern development of finite element method began in the year of 1945 in the field of structural engineering with the work by Herrenkoff. Herrenkoff only to introduce this system in 1945. In 1947, the Levy introduced the flexibility of and force methods, and then 1953 he suggested the stiffness method, which could be promising alternative for the use in analyzing the statically redundant aircraft structures. By using this principle, Argyris and Kalaskis developed the matrix structural analysis method in 1954. This development is the important role that the energy principle would play in the finite element method. The term finite element method first introduced by Clough in 1960 in the plane stress analysis. The most of the finite element was introduced by Clough 1960 in the plane stress analysis, and it used both triangular and rectangular element in that analysis. Most of the finite element work up to early 1960s dealt with the small strains and small displacement, the elastic material behavior and static loading. 1961, the Turner considered the large deflection and thermal analysis problems. In 1962, Dalher introduced the material nonlinearities problem, whereas the buckling problem were initially treated by Galcher and Wedlock in 1963. In 1968, Zinkvik extended the method to viscoelastic problems. The weighted residual method was first introduced by the Galerkins and Ritz methods. In late 1990s, the PC flatbed became the major force right-end analysis. The models with a million degrees of freedom were being run on the disk sites. The supercomputers capable of running 1 trillion operations per second. 1 trillion operations per second. This is the history of finite element method. After going to study about the finite element method, this finite element technique would consist of the series of steps. First one is, you see, the first step is the discretization of problem. That is, the given problem is converted into number of parts. Name it is called the elements. The every element is joined by the points called the nodes. This is the first step, the discretization of the process. Second one is the selection of approximate function. The given element is converted into functions. The problem is converted into functions. This is the second step. Third point is the derivation of basic element equations. After making the function, you need to convert into equations. This is called the element equations. Next, to solve the given equation, that is point number 4 is the calculation of system equations. The equation is converted into some useful parameters. For example, it's having known parameters and unknown parameters. You need to calculate that parameter values. Next one is point 5 is the incorporation of boundary conditions. This problem is converted into some limit values. This is called the boundary condition, where it is applied on the load, how to calculate the results. This is called the boundary condition. The solution of system equations. You need to calculate the solutions by the developed equations. This is the point number 6. Next one is the post-processing. This post-processing is the method of retrieving the results by the solutions. Eighth one is the presentation of result. You need to display the result values. These are all the basic steps of finite element analysis. Basically, these steps is converted into 3 modes. One is the pre-processing, processing and post-processing. The pre-processing having discrete the element to make the approximate functions, the derivation of basic element equations. These are all the pre-processing. The processing means the calculation of system equation, incorporation of boundary conditions, the solution of system equation. The post-processing is the retrieval of results and display of result. These are all the basic steps of finite element method. This is very useful to study about the finite element methods. Thank you.